let's move on to our next session, which is on 3D printing, beyond prototyping. So 3D printing, a lot of excitement, there's a lot of news around it, and I don't have to say that it is a disruptive force in the manufacturing industry. We can ease manufacturing parts and products that are different to manufacture with traditional machinery or laser processing methods. 3D printing is basically God-sent for rapid and iterative functional prototyping, as well as for manufacturing tools, jigs, fixtures, and something that is now moved ahead from the prototyping stage to actually having real applications. So we will have Saroop Chand ji, who's the director of Adroitec Engineering, to talk us through what the future holds for 3D engineering, a little bit about 3D printing, a little bit about Saroop Chand ji. So he's been evangelizing the use of computers since 1976, when IBM left India. He's pioneered the use of CAD/CAM in India, and he's been driving design innovation. For the last 4 years, he's been focused on 3D printing beyond prototyping, and his team has developed unique solutions around that, both in manufacturing industry, artisans, biotechnology, and he has a couple of patents that he holds in burns and deep wound patients around 3D printing. So Saroop ji, all yours.
Okay, I think most of you are from software, and I am from the physical world. Okay, we heard 3 sessions in the morning, which all talked about how AI, how virtual world, how software will be the future. We wear shoes, we wear clothes, we drive cars. That's a physical world. And fortunately, there is a major disruption which is happening in the world of manufacturing itself. And what I want to discuss and what I'm going to talk about is that physical world. Adroitec has been focused on providing design and engineering solutions in the physical world, and there are 4 disruptions which are happening in the manufacturing which are related to robotic. Can I see that? Okay. Which is happening related to robotic, IoT, PLM, and of course the 3D printing. There is it's not that 3D printing is very, very new. It's there for last 20 years, right? It has been there. Today, what has happened is there was a lot of hype which got built up around the 3D printing. People started talking of 3D printing even at the home, right? It has not happened. The hype went down, and today the discussion is how can it be used in industrial application, how can it be used for functional part beyond the prototyping, and that is what is the challenge. It has made an impact. Why it has changed? There is an impact on technology, there is a talk about material, there is a talk of software. To take an example, companies like Dassault, company like ANSYS, company like Siemens, all of them have now piled in to bring in new solutions for the 3D printing industry. Companies like BASF, GKN, SABIC, which were typically manufacturers of the raw material, have started working in 3D printing to ensure that the manufacturing could be done. Material is no longer a limitation for the people. Let's look at what is the need and why 3D printing is becoming critical and necessary. If you look at it, you demand your own products to be very personalized, right? You demand that the products should be able to meet my need in the most efficient manner. The other thing is that as a result, the change orders are happening, new models are getting introduced. Do we see the Ambassador car, which used to change once in 5 years, is now 5 models are being launched by Maruti every year. as a result, when you make so many changes and so many engineering change orders, how do you do tooling? How do you do the manufacturing? How do you do the styling? All of them become difficult. Other very big challenge which comes up is products are becoming smart. And today there is an integration of electronics, software, hardware, all of them go in making the product, and therefore I need to reduce my cycle of design, from design to taking it to the market. Let me take a quick example. All of us are very familiar, and some of you may be running the industry as well. If you look at it, a mixie, if I am a startup or if I am making a new product, would have required hundreds of parts in plastic and in metal. Yes or no? Typically. And if it requires that, what would be the capital cost involved in making the dies? Because the traditional process would be this, which is CNC machine, lathe machine, wire EDM, making a casting die or an injection molding die, and then making jigs and fixtures. These are all typically required in a traditional process. This would require, even for one brand of mixie to be launched, at least 2 crore of rupees in making all these processes. And it would require 6 to 8 month cycle at the best efficiency. What are the limitations which a small scale industry would face? If you look at it, there is a very, very limited capital cost, which all of us need to work on. There is a skilled resources which are limited. Then, as a small company, can you hear me? Because I couldn't see my prompt. So, as a small company, you don't have the vendors, and the vendors will ask you minimum 100 parts to be produced, otherwise they will not come to you, right? Now, it means big inventory. It means large working capital, apart from the capital cost. And if you go to the market, what would happen? You go with one brand of mixie or any of the machines, the guy would say, oh, you're a startup, you're just a small company, you leave the pieces with me, and if there is a sale, I would be able to market it, give you the money. On the other hand, if I go with 3 pieces of mixie and say these are the variants, my cost comes, the market acceptability become very high, my branding become very good. Look at it. What you could see there, you could see as a single machine producing it. And could this be produced? Right? Could this be produced? All of them could be produced from a single machine and simultaneously. When you produce both of them simultaneously, and instead of 1 year cycle, I produce them in 3 days' time. Now, that is the challenge with the manufacturing companies. Different organizations are finding it to be disrupting, who have to deal with the manufacturing as their base. It gives them the higher capital efficiency typically. To achieve this, what did we do? There are companies which are working on materials and big leading companies to produce functional parts. Initially, it was for prototyping, which could only be giving me a form, fit, show. But now there are functional parts which I can use and can deliver. It gives me the speed, and it gives me ability to take it to the market of any size the parts could be. It is so easy to operate that someone was asking me, practically in about 15 to 20 days' time, you should be able to run and start producing the parts. It works for 24/7, and therefore it's a factory on the move. When I have it in my stall, the 3D printer, you can actually see the different parts being produced simultaneously. Companies like Hewlett-Packard, Toshiba are now working to see that can I replace or can I produce parts in thousands of quantity at high speed and in a very short duration. and multiple parts. So there was a customer called one of the special purpose machinery manufacturers. What did he have to do? He had 300 different components which go into the special purpose machinery. He had to stock 50 pieces of each of them and keep it in his godown. Now, which limits him to make a second product or variant very difficult. Now, he sends me the 300 part for machinery number 1. I produce it, send it back to him, and next month he is producing a different machine. He doesn't have to stock any parts. So it has taken away the whole gamut of inventory. It has taken away the whole gamut of keeping the inventory for maintenance of the machine after 5 years, because the machines are going to be used after 5 years, right? I don't have to keep the parts because my digital inventory will produce them as and when I need them. It's not just for end-use parts. It's significantly, a manufacturing factory would require a whole lot of jigs, tools, gauges, fixtures, and things like that. Die making. So if I go to a shop floor, there would be a machine setup requirement, fixture requirement, as well as different type of line balancing options. So a typical factory would require maybe for surfacing, maybe for making smart products, the brackets and the boxes and things like that, which all of us are talking of internet and things like that. How do I make my box? Can I keep it hanging? I can't keep it hanging. If I can't keep it hanging, I have to make a box. I have to provide the brackets, which are EMI protected, which are electrostatic discharge available. All these materials are being worked upon where you can actually work with these materials directly. Company like GE uses it for CMM fixtures, which means measurement fixtures. Companies like ABB use it for robotic end-of-line arm. Or for lathe operation, you need to pull out a part. How do you pull out a part without a fixture? So I just gave you a few examples of either if I have to do the welding, if I'm making a bicycle, how do I do the welding? Can I do the welding easily? I have to make the fixtures. All of them take time and cost. Taking the advantage of it is not just the small-scale companies. It is the big companies which jumped into to be able to use the manufacturing and the 3D printing as a disruptive technology for the day-to-day operation. It's being used by diverse applications, whether it's aerospace, whether it's consumer durable, it's being used for drones, it's being used for biomedical applications. So I put some of them is being used for tooling, end-use part, and the finished products. Materials, you have available ceramic, metal, different metals, whether it's titanium, stainless steel, or any of them. You have biogels. You have, today the tissue is being prepared with the help of it. I personally work on the biotechnology quite a bit, where it has been accepted that the burn and deep wound patients can be cured much faster and much better using the customized smart bandage, which is what we produce. In an automotive company, it could be used for visualization, it could be used for creating the prototype, and it can be used for repair of the dies or making the dies. In biomedical, you could work on implants. Today, the implants are being worked with the help of 3D printing. We just designed a Boston brace, and with the Boston brace, many of the people have the spinal pain. Typically, what do? You put a belt. Now, do I need to keep a belt on? Because that puts the pressure at different wrong points. If I could make a brace which is at the back and can support me the pressure at the place where my spinal cord is affected, chances are I will be able to get my cure and be able to work much more efficiently. I could work with my dental applications like aligners. I could work in aircraft. Can I use it for repair? 3D printing can be used for repair of the existing parts in metal and in plastic. Can architects use it? Thousands of architects are today using it, and now we even have the science where we can make projects like housing directly with the help of 3D printing of any shape. You might wonder, what is the advantage of it? Today I can make my duct, I can make my wash basin, I can make my roof, I can make my slab of the kitchen while printing it together instead of making them as separate parts. Okay? I hope this gives you an idea of how 3D printing can be used very effectively and how different people are using it. Adroitec as a company is located at multiple locations with a team of about 350 plus people who are working in this area of disruptive technology. Thank you.
So thank you, Saroop for that insightful session. Of course, 3D printing is, we hear a lot about it, but these were some real applications, especially being able to manufacture not on a batch size, but just to one, and especially applications on healthcare, what he described. Truly enlightening. May I request Mr. K.K. Mahapatra from the Anand Bazar Patrika to hand over the token of appreciation to Saroop ji.
Thank you very much. Yes. I could have touched printing.